Well, I have a Zalman power supply for repair. Got it off eBay for 99p again. Getting some really good power supply deals. This is built by Sparkle Power. I've already opened it up. It's going to need a clean, but it's got a problem. It's not working like the others. But this is quite nice. It has a double ball bearing fan. It's an NMB fan, I'll show you later. Active PFC, noise killer control, and all that other stuff. This is a Zalman 460 APS. Here's a look at the ratings. Quite nice. But it has a fault, and let me show you. Listen to the sound. Sounds like the transformer's shorted or sparking or something. And this is the ripple that we're getting on the 12-volt line. You know, it's just so much ripple. It's just going crazy. I'll show you the ripple on a different line. Do it on the 5-volt. The 5-volt's not that bad actually, but I don't think. Actually, here it is. It's just going insane. And the 3.3 volt is the worst. I'll try and show you here. Ah, it was originally at 2.9 volts, but it's changed now. But just listen to the noise. I don't know if that's a fan. It just sounds nasty. So, we're going to open this up and diagnose the fault. It's in pretty good condition too, so it must have failed intermittently. But let's open it up. Look at the dust in here. This is pretty much identical, but it has more components to an FSP that I worked on a couple of weeks ago. An FSP 250 watt, but this is a bit more beefier because it's 450 watt. But look at the dust. These type of Sparkle Power designs, these just seem to get loads of dust. Well made though, is the fan. Clogged with dust. I'm going to have to dust this out. Primary bulged? I think our primary cap's bulged. But anyway, I'm going to take this outside and dust it. Okay, so I've cleaned it up, and it pretty much is identical to the 250 watt FSP, but with more components because it's higher wattage. And has the same SPI transformer, Sparkle Power Industry, because it's manufactured by the same people as the FSP. The only difference is that this is over here and there's more components in this one. So on our IEC connector we have 2 Y capacitors and an X capacitor. Then we have a fuse, 2 low filters for positive and negative, X capacitor, low filter with 2 windings, so positive and negative, 2 more Y capacitors, another low filter, and here's our PFC diode and controllers. Goes through the coil, the controllers, goes through the main filter cap. Of course I missed out the rectifier, but it gets rectified before all that. Then goes through our 2 transistors. They make a high frequency voltage. They create a high frequency, for the transformer. Then these output diodes catch that voltage and come in off the transformer, so it's probably about 15 volts or something, and these just regulate it. Then our capacitors are caps on, and we have a couple bulges. There's one there and there's one back there, so they're going to need changing before I could make any kind of assumption about this power supply. So it's time to get to work. Get on soldering caps and then find out what's going on with this power supply, because I don't think it's the caps, but it could be something to do with that. or the caps could have failed because of the other fault that's happening with the power supply. But anyway, it's time to get on with it. Here are the new caps. I'm using Panasonic FR 1000 microfarad 16 volt in the 8mm size, and I just got a KZE there. But I soldered and then I removed it and put a 3300 microfarad 16 volt Zalman in its place. There's one of the bulges, another one, and this one, which was down there, that was bulging too. So I'm going to get these on and then investigate further, see what else is wrong. So I'm done with the recap and it's done. I've used Panasonic, Chemicon, and for the smaller caps, Jamicon. So I've replaced the primary with a Panasonic, same ratings, but I trust the Panasonic way more than the Capson, of course. There are our Jamicons, just the smaller ones. Now I'm using Panasonic FR for pretty much a large majority of the secondaries, and there's one Chemicon KZE back there, and surprisingly that solved the problem, and I'll show you how. Just ignore that IC connector I've just got hooked up, that's just for testing really. But I'm going to flip over the board because I don't want to power it on with the solder facing downwards, and I'll show you how it's solved the problem. Just look at the old caps. Big, cheap, junky caps on one. Hardly weighs anything. This one was bulged and it has glue on it, so I couldn't tell it was bulged, but I replaced them all anyway. Anyway, let me fire this up for you. So if I power it on here we go. 12 volt charges and it's pretty much stable. Look at that. Compared to like the 0.30 volt ripple before, now I've got very little. It still has that noise, but that's probably because there's no load. It's just restricting on the output. So if I check another rail at the 5 volt, 5 volts now pretty much in spec. It's a bit low, but when the power supply gets loaded it should increase. That's in spec though. I check the 3.3 volt. Now this is quite awkward. And look at that. Beats 3.2 or 3.1. And when I first tried it out it was 3.19. Oh no, 2.98. So just proves that it was bad capacitors. Bad capsons. I don't think the TPOs and the OST were bad, but I replaced them anyway. What are these? These are KFs. I've seen these fail before. We had only 2 bulging. This one's actually bulging at the bottom. But there were probably more bad ones because every single voltage line had bad ripple current. Anyway, I'm going to get this back in the case. So it's been a repair success so far. Let's not mess it up now. Right, so I'm getting ready to test this. I'm going to test this for about an hour or two. I just leave it running just to make sure all's good. I didn't test any of the other components like the rectifiers or the transistors. What I was doing is I was recapping it, and then if the problem was still there, then of course investigate further, but the problem seems to have gone away, which was extremely bad ripple. But this has 4 SATA, 4 Molex, 2 6-pin PCIe connectors, an 8 to 4-pin CPU power connector, which you can divide it, and a 24-pin ATX, so this is pretty good. I might even swap this for my Corsair 6 or 30, but I'll see what happens. But this is a fairly good power supply. If I show you the rails. What I'll do is I'll hook up the meter and that and show you that it's all good, and I'm going to run this for a while. That should be pretty much it. So on the 12 volt with the fan plugged in, we have 12.31. Flickers a bit, but that's normal for a switch mode power supply. It's pretty much stable. And I've also noticed this thing is quiet. Really quiet. I can't really hear the fan. I can hear the PFC and whatever's making that a bit whining noise, but that's not loud either. 5 volt, we have just under 5 volt, 4.99. But that's good enough. If I test the 3.3. Pretty much 3.3. 3.33 actually. So that's good. Good power supply. Another 99p eBay win. So good fix up. Use Panasonic's, 1 Chemicon and 3 Jamicon. And this is a rock stable power supply now, I hope. If anything fails though, I'll keep you updated. Thanks for watching.